Hello everyone, welcome to Rogues Academy. Some times ago, I started creating tutorials on how to send data from different IoT boards to different IoT cloud platform. In this tutorial, I'll be walking you through the process of sending data from NodeMCU to Arduino IoT Cloud. We're going to start by looking at the hardware connection, how to set up the hardware connection. We're going to be sending data from a DHT11 sensor. We're going to be taking the temperature, the humidity, and also we are going to be controlling an LED from the cloud. I'll be walking you through the process of setting up the hardware, setting up the software, and during the course of this tutorial, we're going to see a bug in the online Arduino editor, and we're going to be seeing how we can fix that bug together. So let's start with the hardware connection. Here we have the hardware connection. I have my NodeMCU connected to DHT11. For this tutorial, I'll be using a DHT11. So it has 4 pins, and the connection goes like this. This is pin 1. It's connected to 3 volts. 3 volts, connect pin 1 to 3 volts on the NodeMCU, and connect a 10k resistor between pin 1 and pin 2. And from pin 2, connect it to D4. That is pin 2, D4 of the NodeMCU. And the third pin is not going to be connected, but we are going to connect the 4th pin to ground. So once again, connect pin 1 to 3 volts of the NodeMCU. You connect a 10k resistor between pin 1 and pin 2, and from pin 2, connect to D4. Omit pin 3. Pin 3 we are not going to use it, and connect pin 4 to the ground of the NodeMCU. So now I will plug it in, and we are going to do the necessary setup on the laptop. After making all necessary hardware connections, the next thing is to go to the web browser and make the software setup. I'll just give a quick overview of what we're going to be doing in this tutorial. The first thing is to sign in and set up our Arduino Cloud account. After that, we're going to configure our dashboard, and also we are going to create a theme. So from this, we're going to be sending data from the NodeMCU to Arduino IoT Cloud. Also, we are going to be writing the code using the web-based Arduino IDE, and after that, we're going to be writing the same code using the offline Arduino IDE, which is the software you are used to. So the first thing you want to do is to come to a web browser and search for Arduino IoT Cloud. So you're going to look for a link, the one that says cloud.arduino.cc. Click on the link, and then these are environment. Here we have the Arduino IoT Cloud. So from options here, select IoT Cloud. You also have web editor. We have manager for Linux. What you want to do is to select IoT Cloud. So another tab is going to be open where you have your work environment, where you have access to create a new thing, and also you can set up the sketch. If you look at this web page, we have things, we have dashboard. This is where we are going to configure our dashboard, how we want our device, our data to look like. We have devices, these are the devices that we have connected, integrations, and we have different templates that we can make use of. So what we want to do is to create thing. So this thing is untitled. I'm going to give it temperature monitor as the name of our thing. So after giving it a name, we're going to add variables. These are the variables that we're going to be measuring. So this variable depends on what you want to use. If you are going to be sending, for example, 5 telemetry messages from your NodeMCU, you just want to add 5 variables: temperature, humidity, heat index, LED state, and others. Also, if you want to control something from the cloud, let's say for example you want to change the state of an LED using the cloud platform, you also have to add the variable. It might be an LED variable, it can be a electric motor variable. So I'm just going to add 3 variables, one for controlling LED. So under variable type, select boolean, since it's going to check in the state whether it is on or off, that is true or false. So I'm going to select boolean and click on add variable. So that is added. The same way too, I'm going to be adding temperature. And under variable type, I'm going to search for temperature. If you search for it, it might not pop up. You should just click this and search for temperature. So I have temperature sensor degrees Celsius. So click on temperature sensor, that's our variable type. So leave everything else as it is and click on add variable. Also, we are going to be adding humidity. So we are going to be getting two data from DHT 11 sensor, the temperature and the humidity. So I'm going to be using these two data on the cloud. So the same way, also check the energy and search for temperature sensor. So we're going to be adding the variable. So we have our three variables added: humidity, LED, and temperature. So after adding the variable, the next thing to do is to link your device. So don't forget the first thing is to add all the necessary variables. There's a mistake here. Under my humidity, I have to edit this. Since humidity is in percentage, I've just searched for anything and percentage. So we can just use integer number for our humidity, and we know it's represented in percentage. Save. So now we've added three variables: humidity, LED, and temperature. So the next thing to do is to link a device and also set up our network. So to set up the device, we're going to click on this, select device. So it's going to load a lot of devices that we can use. Okay, I already created the device the other time. So I'm just going to set up a new device. And then we have two options to set up an Arduino device or set up a third-party device. Since we're not using Arduino device, we're going to click on set up a third-party device. And you see we have ESP8266, ESP32, and also LoRaWAN. So we're going to click on ESP8266. That's because we are using a NodeMCU, and search for NodeMCU. Now here we have NodeMCU. Just select the type you are using. In this tutorial, I'm using NodeMCU 1.0 ESP12E module, and click on continue. So I'm going to give this device a name. Let me give it and don't forget, there should not be any special character there. You can use underscore. I'm going to call this my temp monitor. So that's the name I'll be giving to this device. Click on next. So after setting up your device, it's going to provide a set of keys, which is the device ID and also the secret key. So make sure you copy this device ID and also the secret key. It's very important to copy the secret key. You might not have to use the device ID most of the time, but make sure you copy the secret key. And also there's an option to download as PDF. What I used to do is to download as PDF in case I'm going to need it anytime. So after clicking on download as PDF, it's going to be saved on your system, and we can make reference to this later. But I'm still going to copy the secret key. I know I'm going to be using this. So after copying it, check this box and click on continue. And with this, you are all set. Click on done. So we can see that our device has been set up, and we have a status there that says offline. That means we have not connected our device to the cloud. So we can change the device and also we can detach it. So after that, the next thing to set up our network. So we are clicking on configure to set up our network. Here you're going to input your Wi-Fi name. My Wi-Fi name is Raspberry, and I'm going to be also the secret key that we copied the other time. It's some time for us to use it. If you didn't copy your own, simply go to to download. Don't forget we downloaded it the other time. And this is the Arduino secret key PDF. So we are going to click on this. So this here we have the secret key. So I copied it the other time, so I'm going to just paste it in. So we're going to save this. Let me do that again. So now our network has been configured. So we have everything set up. Now before we do that, this is basically the overview of setting up our cloud environment. So everything we are doing in this particular tab is to set up our variable once again. After setting up the variable, what we want to do is to set up your device. This way you're going to select the type of device you are using. This is going to vary depending on the device you are using. If you're using an Arduino board, you have to select an Arduino device. If you're using NodeMCU, like what I'm using now, you have to select NodeMCU. After that, you configure your network. You're going to enter the Wi-Fi name, the password, and also the secret key that was copied when the device was created. So that's basically all you have to do in setting up your environment. The next thing now is to configure our sketch so that we're able to upload code from the Arduino Cloud to our NodeMCU. So click on Sketch to generate a new sketch. So here you are in the Sketch tab. To generate the sketch, take note that the sketch that you are generating is going to be making use of the variables that was created here. Take note of this. We have int humidity, bool, LED, and cloud temperature sensor temperature. So it's going to be making use of all these three variables. So therefore, you have to generate a new sketch. So to generate a new sketch, just click on Generate Sketch. Okay, before I proceed, we have our new sketch here, and I would like to point out that if you already created a sketch before and you delete it and you want to create a new one, just like the case at the other time that I've generated a new sketch, you might have to clear your browsing data first. You might have to clear your cache because it won't work. If you click on generate sketch immediately, it won't work. If you already have a previous sketch that was deleted, you just have to clean your browsing data, and that's what I did, and it worked. So here I have my new sketch. Don't forget, if you already have a sketch that was deleted, you have to clear your browsing data for you to be able to generate a new sketch. And here I have my new sketch. This is the code I'm going to upload. I'm going to edit it the way I like, so it's going to communicate between my NodeMCU and my Arduino Cloud. So I'm not going to be working in this tab now. What you want to do is to open full editor. So I also like to point out, if you have not been using your Arduino with Cloud before, you have to download something called the Arduino Cloud Agent. You have to download something called the Arduino Cloud Agent. I'm very sure if you are new to this, if you're on this page already, it's going to prompt you to download the Arduino Cloud Agent. Make sure you download it. But if it's not showing it, you can just search for Arduino Cloud Agent. If you search for Arduino Cloud Agent, you see you have it here, and so I will just run. You can check and read about it on this page, and it will guide you on how to download Arduino Cloud Agents. Once you have Arduino Cloud Agents downloaded, it's going to be showing as an icon on your taskbar. It's going to be showing as an icon on your taskbar. That is Arduino Cloud Agent. Note that before you can use the Arduino editor, you have to download the Arduino Cloud Agent. I'm very sure if you are using your cloud environment for the first time, it's going to prompt you to download the Arduino Cloud Agent automatically. So that's it concerning that. So yeah, we are going to be working with our software and how to communicate between the Arduino NodeMCU and the Arduino Cloud interface. Before I do that, I'm going to go back to, before I start writing my code, I'm going to go back to Arduino IoT Cloud and I'm going to create a dashboard. Don't forget, the first thing we did was to create our setup. We get our sketch, we generated a new sketch. Now, before editing the sketch, I'll just create a dashboard. You can do this after you create your sketch. You can do this anytime. But before you upload your code, make sure you create your dashboard. So dashboard is how I want my interface to look like after sending data from the NodeMCU to Arduino IoT Cloud. So here I'm going to click on add. After clicking on the pencil, click on add. So the first I'm going to add in a switch. So this is a switch for turning on the LED. I'm going to be using a switch on the Arduino IoT Cloud. I'm going to be controlling a particular LED from the IoT Cloud. So here I'm going to call this LED switch. So the next thing is to link a variable. Which variable will be controlled? You'll be controlling the LED switch. I'm going to select LED and click on link variable. So after that, click done. Next thing is to add. I'm going to go down and add a gauge. So this will be for my temperature. I've named this temperature gauge. So next is to link variable. I'm going to link my temperature and click link variable. So after that, click done. So next I'm going to be loading a value. This I'm going to put my humidity there. Forget this will be in percentage. Click on link variable and I'll select humidity and I'll click on link variable. So done. So next thing I want to add is to add a chart for my temperature. I would like to display my temperature in a chart. So please click on chart and name this temperature chart. So again, click on link variable and select your temperature. After that, click on done. So I have my dashboard display. I have the LED switch, I have the temperature gauge, I have the humidity value, and I have the temperature chart. You can also name this. I'm going to give this temp monitor. So after setting up everything the way you want to create it, just click on the preview. Instead of pencil, click on preview. And this is how our dashboard will be displayed. So now we are done setting up our dashboard. You can go back to theme and set up our sketch. So click on our temperature monitor. This is theme we created the other time. And go back to sketch. I just leave it on this tab and I can come to the new tab that was created the other time, which is on the Arduino editor. And here I have my tab. This is where I'm going to edit my tab, edit my sketch to communicate between the Arduino IoT Cloud and also the NodeMCU. Okay, first let's go through this code and see what we have here. So some variables are declared automatically. If you check here, all our variables are declared automatically. We have bool LED, int humidity, and cloud temperature sensor temperature. Here we have include thingsproperty.h. Here we have our thingsproperty.h, which is the header file. So these are setup function. We have serial.begin, which is 9600, delay 1500. So we have some cloud properties that has been set for us. And here we have our loop. So now our main task is to tweak this code so that it's going to work with what we have on our hardware. But before I get to that, I would like to mention and point us towards that. Don't forget we are using a NodeMCU and a DHT sensor. First of all, we have to make sure that we have the necessary library that's going to make the DHT work available on the IDE. Now, if you are using the Arduino IDE, which is the offline version, it's also the same thing. If you go to the library manager, you're able to download the library that you're going to need. So also, if you want to download the library that we are going to need on the Arduino online editor, just come to libraries here. Don't forget, our task is to download the library that we need so that the DHT11 is going to work. So click on Library Manager, and then we're going to search for DHT. Now I'm going to be using this. So if you want to download any library, just click on the fifth right, just click on the star, it's going to download the library for you. If I click on this now, it's going to download the library for me. So you can see I've already clicked on the star, so it has downloaded the library. So I'm using the Adafruit DHT sensor library. So after you have done downloading the library, which is by clicking on the star button, just click on done. So then we can, what we are going to do first is to test. But before you do that, there are some things that you have to reconfigure and make sure it's working perfectly. Make sure that at the top bar here, what you have is your board, which is NodeMCU 1.0 in this case. So make sure it's set to the right board and make sure it's set to the right COM. So now I'm going to click on examples. This, like, we are working with normal offline IDE. So I'm going to look for an example from the library which I just downloaded, which is the Adafruit DHT sensor library. So this is the library I downloaded, and I'm going to click on DHT set texter. So I have this code here to test my DHT if it's working or not. There are some things that we have to change in this code to make it work for us. The DHT sensor is from this code is connected to pin 2, which also is the same thing from our own setup. And here, the DHT type that's being used is DHT22. I'm going to comment this out. So it's telling us that you have to create a copy if you have to edit it, just like the way the offline editor used to behave. So I'm going to just add text to this. Okay. I think I'm having a problem with my internet here. Okay, I think everything has been resolved. So I've commented out DHT22 and I will uncomment DHT11 because I'm using a DHT11. And with this, I think I'm good to go. Okay, I'm good to go. So I'm going to upload this to my Raspberry Pi. It's going to automatically upload to the physical hardware. So let me click on verify and save. So I'm going to see a busy tab here. So once it's done, we're able to upload the code. It's going to upload directly to this board that's been shown here, NodeMCU on COM19. Okay, it's done. Then let's click on upload and save. So it has started uploading. You can see upload started. So it's starting already. We have 30%. And it says flash complete. So now we are done uploading. And if you want to check the output of our DHT, let's go to monitor. So here you can see that the code has been successfully updated. So we have data coming out from the NodeMCU and it's been displayed on the online editor. So now, after making sure that the DHT has been successfully collected and also the data is being sent to the online editor, we can now proceed to edit our original file, which is the sketch that was generated after creating the device. So I'm going to click on disconnect. So now we're going to be editing. Let me go back to Sketchbook. So we're going to be editing this file and also this file to make sure that our DHT data is successfully displayed on dashboard. Okay. The code DHT tester test is the one responsible for taking data from the DHT and displaying them on the serial monitor, while the code temperature monitor is our original sketch file. If you study this file very well, like we did the other time, you see that it's just a template, like a skeleton. This is where we just input our code. You can see that from the for loop, it says your code here. So what I'm going to do is that I'm going to copy this now. Since we can open the two of them simultaneously, I'm going to copy this code and paste it in my notepad. Then I open temperature monitor. So I'm going to be copying some of the variables that will make the DHT to work from this particular file. So I'm going to copy include dht.h and I'm going to paste it in our original file. Okay, I'm going to copy this also. As define DHT pin 2. Okay. So I'm going to copy this too. As define DHT type DHT11. I'm going to upload the code and I'll put the link in the description. So if you can't copy it, just feel free to check this description and you see the code. Okay, we are done with that. So let's go to setup. So we're going to copy dht.begin from the setup and I'll upload it in my make code. So let's go to setup here. So after serial.begin, I'm going to insert dht.begin. So that's that from the setup. Then going to loop. The first code I have here is float h equal to dht.humidity. I'm going to copy this. So I'm going to void loop. Okay. Also, I will copy float t equal to dht.read temperature. And I will copy, paste it here. Okay, I've copied humidity and I've copied temperature. So since I'm not going to be printing them out in the serial monitor, yeah, what I'll just do is that I'll just set my variable. I'll just set temperature to be equal to T. And also humidity equal to H. So where did I get it? If you go up, scroll back up. So we have these two variables that was automatically declared. We have humidity and also temperature. So you just have to set these two to our defined temperature and variable. Temperature and humidity, in this case, which is H and T. So you have temperature to be T and humidity to be H. So we are going to, that's where we are going to stop for loop. And for our LED, so I'm going to copy this code. It's going to make the LED to come on when it's on and also go off when it's off. I'll just paste it here directly. If LED is 0, digital write to EBI, and if LED equal to 1, digital write 2 below. So that is that with the code. I'm done with the code now. So uploading this is going to make our data displayed on our dashboard. So let me verify this. So we're trying to upload the code. We're trying to verify it. I received 2 errors saying DHT was not declared in this scope. I just have to copy this and I pasted it. So I forgot to copy it before. Now after trying to verify it again, I got another error saying LED was not declared in this scope. So if you go down, you see that we used LED. Yeah. If LED equal to 0. So I think this is like a bug on the Arduino online IDE. But how to resurface is this. If you go up to the automatic variable that was declared for us, you see that the way LED was written is quite different from the way it was written here. You have some kind of a capital letter L here, and if you scroll up, you have some kind of number 1. So what I did was to change this to capital letter L, So I changed the automatic variable to capital letter L. So not only that, I go back to my Arduino IoT Cloud. So I go back here, go back to my setup, and I came back to LED and edit this. So now just come to description and change this to capital letter L. So after that, you just click on save. You see it has changed here. If I go back to my editor, I change it to L also, then I can verify it now. And I hope with a little bit of luck, the error should be gone. Okay, I'm refilling the same error. So I'm going back here. If I go back to sketch, okay, let me just open this in full editor. So I opened another full editor and let me try to verify it from here. Okay, I've not selected the board. Okay, so let me try and verify this. Wow, and that's worked. So I have success there. So the code has worked. Don't forget, just I'm going to close this down since I'm no more using it. So what we did was to go back to IoT Cloud. I changed LED from 1ED to LED, and I opened the sketch and opened the sketch again in full editor. So that was what led us here. So now the code has successfully compiled. So next thing is to upload the code and see its behavior. So we have connected to Arduino IoT Cloud. The thing ID is this. So let's wait until it starts uploading. Oh, and there we go. The code has been successfully uploaded. So let's go to monitor our output first. So after our device has been successfully connected, you can go back to Arduino IoT Cloud, and I can go back to scene. So if I click on scene, you see the started there, it has sent to online. So it used to be offline before, now we have it online. You can go to dashboard then. This is the dashboard that we created. You can click on it, and then we have our value being displayed. So this is our temperature gauge and this is our humidity value. So to see the temperature chart, here we have our temperature chart which is being uploaded today. If I click on live also, so our humidity has changed to 12. We still have temperature as 31. So turning on and off this LED is going to make the LED connected to the Raspberry. Turning on and off this LED is going to make the LED connected to the NodeMCU to be coming on and going off. So this is our temperature chart. Our temperature value is changing and our humidity value is changing. So that's it on how to connect your device to Arduino IoT Cloud. In this tutorial, we use a NodeMCU and connect it to Arduino IoT Cloud. I can go back to Arduino editor. Don't forget, this is my code. I'm going to put this in the description below so you can download, and if you want to make use of it, feel free to do so. And this is my dashboard. So this data can also be viewed on your mobile phone by downloading the Arduino IoT mobile app. So I can change it to mobile view. This is how it's going to display on mobile phone. If you want to edit it, just click on this pencil. You're able to edit anything there. And once you are done editing, click on the preview. So I'm going to change this back to desktop layout. And on my mobile app, if I open
the Arduino IoT Cloud, which is IoT remote. I have the same dashboard that I'm seeing on my system. I can see it on my mobile phone too. So I can monitor this both on my system and also on my mobile device. So just go to Play Store and download IoT remote, and you have the Arduino IoT Cloud to yourself. So you have the humidity value displayed, the temperature grid, and also the temperature chart displayed. So that's that concerning how to view your data using your mobile phone.
So that's it on how to connect NodeMCU to Arduino IoT Cloud. In next tutorial, we're going to be looking at how to connect a Raspberry Pi to Google Cloud Platform. So see you then. If you like this tutorial, don't forget to like and share, and just subscribe to the channel for more like this. So thank you.